The effectiveness and safety of solar power systems heavily depend on the proper selection and use of wire gauge. The right wire gauge ensures efficient power transmission, minimizes energy loss, and prevents potential hazards. This blog will explore why wire gauge is critical in solar power systems, common mistakes to avoid, and best practices for choosing the appropriate wire gauge for your solar setup. Understanding wire gauge and its role in solar power systems. What is wire gauge? Wire gauge refers to the diameter of the wire, which affects its electrical properties such as current carrying capacity and resistance. The gauge system is commonly used to specify wire sizes. A smaller gauge number indicates a thicker wire, while a larger number indicates a thinner wire. How wire gauge affects solar power efficiency. In solar power systems, wire gauge plays a crucial role in determining how efficiently power is transmitted from the solar panels to the various components of the system. Thicker wires, lower gauge numbers, have lower resistance, which means less power is lost as heat during transmission. This leads to higher overall efficiency in the system, as more of the generated power reaches its intended destination. Safety implications of incorrect wire gauge. Using the wrong wire gauge can have serious safety implications. If the wire is too thin for the amount of current it needs to carry, it can overheat, leading to insulation failure, short circuits, and even fire hazards. Proper wire gauge selection is essential to ensure the safe operation of your solar power system, protecting both your equipment and your home. The wire gauge required for solar power systems depends on various factors such as the type of devices, distance of wire runs, and power requirements. Examples of wire gauge selection in real installations. In a typical residential solar power installation, the wire running from the solar panels to the charge controller might be 10 GA, ensuring minimal voltage drop and efficient power transfer. From the charge controller to the battery bank, an 8 GA wire could be used to handle the higher current safely. For the high power connection from the battery to the inverter, a 4 GA wire would be appropriate to prevent overheating and energy loss. Factors to consider when choosing wire gauge for solar power systems. Current capacity and wire gauge. To select the appropriate wire gauge, you need to determine the current requirements of your solar power system. This involves calculating the total current draw of all connected devices. For example, if you have multiple devices drawing different amounts of current, add their values to get the total current requirement. Voltage drop and its impact. Voltage drop occurs when the voltage decreases as the electrical current travels through the wire. Excessive voltage drop can cause devices to malfunction or operate inefficiently. To minimize voltage drop, use a thicker wire gauge for longer runs or higher current demands. Aim for a voltage drop of less than 3% for optimal performance. Environmental considerations. Environmental conditions such as temperature, humidity, and exposure to chemicals can affect wire performance. Choose a wire gauge with appropriate insulation and properties to withstand these conditions. For instance, wires exposed to high temperatures may require a thicker gauge or special insulation to prevent degradation. Common mistakes in wire gauge selection for solar power systems. Underestimating current requirements. One of the most common mistakes is underestimating the current requirements of your devices. This can lead to using a wire gauge that is too small, causing overheating and potential fire hazards. Always calculate the total current draw accurately and choose a wire gauge that can handle it comfortably. Ignoring voltage drop. Failing to account for voltage drop is another frequent error. Long wire runs with inadequate wire gauge can result in significant voltage drop, leading to poor device performance. Always consider the length of the wire run and select a wire gauge that minimizes voltage drop. Using inadequate quality wires. Choosing low-quality wires to save costs can compromise the reliability and safety of your solar power system. Invest in high-quality wires with good insulation properties to ensure longevity and performance. Opting for copper-clad aluminum, CCA, wires, which feature an aluminum core coated with copper, offers a cost-effective alternative to pure copper wires while maintaining good conductivity. CCA wires are particularly suitable for low-power devices and shorter runs within your solar power system, providing an affordable option without compromising performance. Best practices for selecting and using wire gauge in solar power systems. Using a wire gauge calculator. A wire gauge calculator can be a valuable tool in selecting the appropriate wire gauge. These calculators allow you to input the current, distance, and acceptable voltage drop, providing you with the recommended wire gauge for your specific setup. Consulting professional guidelines. Always consult professional guidelines and standards when selecting wire gauge for your solar power system. These guidelines provide valuable information on current carrying capacities, voltage drop considerations, and installation practices to ensure safety and efficiency. Regular maintenance and inspection. Regularly inspect your wiring for signs of wear, corrosion, or damage. Conduct periodic maintenance to ensure that all connections are secure and that the insulation is intact. This helps maintain the efficiency and safety of your solar power system over time. Conclusion. Choosing the right wire gauge is a critical aspect of designing and implementing solar power systems. By understanding the importance of wire gauge, considering key factors such as current requirements and voltage drop, avoiding common mistakes, and following best practices, you can ensure the efficiency, safety, and reliability of your solar power network. Embracing cost-effective solutions like CCA wires can further enhance your project's value without compromising on quality. With proper planning and attention to detail, you can achieve optimal results in your solar power projects.